In this video, it's our last video for the kinematics unit. We're going to be looking at projectile motion. So we're going to look at what a projectile is and then how to solve problems using projectile motion. So first of all, when we're describing projectile motion, we have to think about it in terms of x and y. So in our last video, we learned how to split vectors into horizontal and vertical components, and that's going to be really important for this lesson because sometimes we're going to have to use x motion, sometimes we're going to have to use y motion. The other important thing to notice is that we are dealing with parabolic motion, and so remember that when we're at the top of the parabola up here, for a very brief second, our v2 is going to be 0 because when it goes up, it has to stop and then it starts falling. So let's try and remember that when we're doing our problems. So here's our first example. So this example is one where something is being launching a projectile horizontally. So just keep track of the difference between the two examples we're going to do. So in this case, we have a beanbag is thrown from a window that's 10 meters above the ground with a horizontal velocity of 3 meters per second. In the first part, we're going to figure out how long it will take for the beanbag to reach the ground. So let's write down what we know. So we know our delta D is 10 meters. And we know our Vx is 3 meters per second. We know our acceleration, which is in the y direction, just so we know, is 9.8 meters per second squared. And we're being asked to figure out our t. We also know that our Vy initial is going to be 0 meters per second because we're assuming that it is launched directly horizontal. So our Vy, we would have no velocity in the y direction. So when we're asked to figure out how long, we're looking for our time of flight. And time of flight is going to be dealing with vertical motion. So it's going to be dealing with motion in the y direction. Okay, so time of flight, think y motion. Okay, so we need y motion. So when we're doing this, so we're going to ignore that Vx for right now from this question. And we want to figure out time. We have a velocity, we have an acceleration, and we have a displacement. So we need to use one of those 5 key equations for motion to figure out our time. So I'm going to use this equation here. So again, you can use other equations, but that's the one that I'm going to use. And so let's remember that our V1y is 0, so we really don't have that term. So that then gives us an easier equation to rearrange. So I've just dropped the deltas here just to make it a little bit easier. So I'm going to multiply both sides by 2. Then I'm going to divide both sides by a and take the square root. So if rearranging equations is still difficult for you, I should be seeing you for some extra help, or you can go back and review some of the other videos. So there we go. Let's go ahead and put our information in. So we have 10 meters, and we have 9.8 meters per second squared. So we get 1.43 seconds. It's important when you're doing a question that you might be using that time for in part B to keep extra significant digits so that we avoid rounding errors. We are going to, though, make a statement or circle our answer rounded to the correct number of sig figs. So the answer for A would be 1.4 seconds, but we're actually going to use the time in part B. So we're going to use the 1.43 seconds just to help with some rounding errors. If you don't, it's okay. Your answer just might be off by a little bit. So for part B, we're asked to determine the horizontal distance. So we're looking for the range. And so when we're dealing with the range, we're dealing just with motion in the y or in the x direction. So we have our Vx initial is 3 meters per second, and we have our time, because we're going to assume that our horizontal and our vertical motion happen at the same time. So we don't know an acceleration in the x direction. So we don't want to use one of the key equations. We actually want to go back and use that very first equation that we used for velocity, which is v equals d over t. And then to get d by itself, we would be multiplying both sides by t. So we actually can go back and use that really basic equation. And that's, again, because we don't know our acceleration in the x direction. So we're going to use that 1.43 seconds just so that we don't have rounding errors. I'm just going to go back and put x's there beside my... So my dx rounded to 2 significant digits is 4.3 meters. So that's the range. So that you can see it in the picture there. There's your range, your dx. So that's what we've just found. So in our next example here, we are talking about something that has a projectile with an angle to the horizontal. So the very first thing I would like you to do is to calculate your Vx and your Vy. So here we've got a velocity of 9.4 meters per second, and we are 40 degrees above the horizontal. So before we do any calculations, let's go ahead and calculate our Vx. And so again, when we want to calculate the x component, we're doing our initial velocity, which is going to be the 9.4, times cos theta. So again, that's in the last video. So if you need to, go and have a look at that again. So we're going to have 9.4 meters per second, cos 40. So our Vx is going to be 7.20 meters. Again, we're going to carry an extra significant digit there. If we needed a direction, we could say to the right or to the east, because if you look at that picture, the ball is going to go to the right or in the east direction. So that's our velocity in the x direction. We're going to do the same thing for velocity in the y direction, only this time we're going to use sine theta. So 9.4 meters per second. And then sine 40. So our Vy is going to be 6.04 meters per second. And we could say up, I mean, it's going to go up and then it's going to go down, but that initial velocity is in the upwards direction. Okay, so before you do any calculations, you're going to need to use those values because we've already discussed that the time of flight is going to be y and the range is going to be x. And then max height is going to be dealing again with y direction. So you're going to see we're going to need to use our Vx and our Vy. So it's a good idea to just calculate those. So just a new slide so that we can work away. So time of flight again is in our y direction. And so let's write down what we know. So our dy is 0 because the ball is going to go from 0 back down to 0. So our displacement in our y direction should be 0 meters because that's what that level part in the question is telling you, that you're dealing with a level surface. So we're trying to find our t. We know our Vy, we just calculated that. And we know our acceleration because it's a projectile, it's dealing with the force due to gravity. So we're going to use that exact same equation that we used in the first example. So what we need to realize again is that this is a parabola. So this is quadratic motion. And if our dy is 0, we can actually, we're going to put our information in. Okay. So I'm going to put my Vy in, 6.04. I'm not going to include units just so that it's a little bit easier. Then we're going to do 9.8 t squared. I'm going to go ahead and I'm going to just reduce that. So 1/2 times 9.8 is 4.9 t squared. And then hopefully you remember from your math that if we have 0, you can either use the quadratic equation or we can take a t out and then we can set each one of those equal to 0. So I'm going to kind of try and fit it in over here. So the first one we have 0 equals t. Okay, so we have 0 seconds, which makes sense because that would be our 0 seconds. We really want to know that time. So then we're going to do 0 equals 6.04 plus 4.9 t. And if you rearrange that, I'm running out of space. I'm going to guess that you guys can do that. T equals 1.23 seconds, and we're going to round that to 1.2 seconds. Okay, so again, from here, you could either use the quadratic equation or realize that you can take a t out and then set each one of those bracketed things. So if I can put brackets around my t here, equal to 0 and then solve. And we always want the number that's a real number, okay? So we want that 1.2 seconds. Again, we're going to use that 1.23 in other. So range is x. We don't know our acceleration in the x direction, but we do know our time, and we do know our vx. So we want to figure out our dx. So we're going to use that initial equation that we learned. And so again, dx is equal to vx times t. So we get 7.2 meters per second times, again, we're going to use the 1.23 seconds, but here in our final answer, we will round so that we just have 2 significant digits. So we get 8.9 meters, again, in the right direction or the easterly direction, whichever you would like. So the last one is our max height. So again, we're back to dealing with vertical motion, and we have to remember that at the very top of that parabola, our Vy2 is going to be 0 meters per second. Okay, so we have our initial Vy. That was that number that we calculated at the very beginning, 6.04 meters per second. We know our acceleration is 9.8 meters per second squared. And we want to figure out our dy. So we're going to use the v2 squared equals v1 squared plus 2ad. Okay, and those are all in the y direction. So if you want to go and put the y's in, feel free. I'm not going to show you how I'm rearranging this equation. You can always go back and watch those other videos. So that's our rearranged formula. So dy equals, so we're going to have 0 squared minus 6.04 squared all over 2 times 9.8. So I'm just going to go up here. Sorry, I'm running out of space. So our dy rounded to 2 significant digits is 1.9 meters. And again, that's up. So that was actually a fairly long review of projectile motion, but hopefully it makes a little bit more sense. Feel free to check out the examples in your book as well. They work things out a little bit differently than I have. Use whichever method works best for you.